our syllabus, that is hydrocarbons. So what is the meaning of this hydrocarbon? Hydro means what? Hydrogen. Hydrogen, yes. And carbon means what? The carbon that we are learning from the so many classes, right? So there will be a combination of these two. Carbon and hydrogen will be there in this entire chapter. And heteroatoms, you all are knowing about heteroatoms. So sometimes heteroatoms will be coming to replace the hydrogen, and there will be a different kind of compound will be there. And how this will be there, so that we will be going to understand in this today's class. Is that okay, everyone? Now see here. Hydrocarbons. Now. So actually in today's class, we have seen these things in our, last class about what? Electron donating group and electron withdrawing group. Guys, you have revised these things or not? Please tell me. OH, NH, OR, NHR. These are what? Electron donating or electron withdrawing? What are these? Increase the rate of reactions involve a nucleophilic attack, right? Increase electron density in pi system. So these things we have seen, right? So that we will be discussing now. We are going to discuss about first the saturated compounds, saturated hydrocarbon, unsaturated hydrocarbon, and aromatic hydrocarbons, right? What is the meaning of this aromatic hydrocarbons? I hope these two things you all are knowing. Unsaturated double bond or triple bond will be there, so it will be unsaturated. Saturated means single bond will be there, then it will be what? Saturated. Aromatic means what? What is the meaning of this aromatic compounds or aromatic hydrocarbons? So there will be a pi and single bond in conjugation, so that will be known as what? Aromatic compounds, aromatic hydrocarbons. Or there are different there are different conditions by which we can see that this is a aromatic hydrocarbons, right? So there are rules for this aromaticity. So here you can see that if double bond is present in conjugation at alternate position, then also it will be called as what? Aromatic hydrocarbons. Is it okay, everyone? So what is the meaning of this aromatic? If double bond this is one condition for this aromatic compound, right? There are another methods by which we can see that this is aromatic or not. Aromatic is there, anti-aromatic is there, and non-aromatic is also there, right? But first of all, we are discussing about the aromatic compound. What is this aromatic that I am telling you? And the one condition that I am telling you about the aromatic, right? The one condition that is what? Other conditions are also available, right, in the market, but we are not taking that here, right? That we will be seeing when the aromatic compound, especially we are going to learn that aromatic compound, then we will be going to see that, right? Right now, just for the introduction part, if double bond is present at alternate position, so that will be called as what? Aromatic compound. But every double bond conjugation will not be the aromatic compound, but every aromatic compound must be having a double bond in conjugation. Is it okay? Is it okay, everyone? Now, come to the point. So saturated, the hydrocarbon which contain only carbon-carbon single bonds are called saturated hydrocarbons, right? So that I have told you. Unsaturated hydrocarbons, the hydrocarbons which contain carbon-carbon multiple bonds, double bonds or triple bond are called unsaturated hydrocarbon. Depend upon the multiple bonds, double bond or triple bond, they are further classified as alkenes and alkynes. That I have told you in the very beginning of the classes of the organic chemistry, that if double bond will be there, it will be alkene. If triple bond will be there, then it will be alkynes. Yes or no, guys? Do you remember those days of our organic chemistry when I have started the organic chemistry? Do you remember those days? Yes or no? Once upon a time, when I was going through this alkene, and alkyne, and you were a small kid and you were just about to learn organic chemistry, that is single bond between carbon will be called as ANEAN. That I have just pronounced like that only, and YNE. ANE for single, ENE for double, and YNE for triple bond. Yes or no, guys? Are you comfortable? Yes? Okay. Now, come to the next point. So this is ethene, butene, but1-ene. All these are what? Alkene only. So can anyone tell me that? Can anyone see, guys? We can make methane, right? From one carbon we can make methane. Is it possible to make methane? Is it possible to make methane? Netara, what do you say? Is it possible to make methane? So carbon cannot form triple bond with hydrogen. First point is this. Carbon cannot form triple bond with hydrogen. Hydrogen is not much having the capacity to form triple bond, right? It is, the hydrogen is having only capacity of forming what? A single bond, right? So whenever there will be a double bond and triple bond will be there, so there must need two carbon at least, right? And why we are seeing ENE and YNE? They are the double bond between the carbon atom, not between the carbon and hydrogen or carbon or oxygen, right? Carbon can form double bond with oxygen, but it will not be a what? Alkene. Alkene will be when there will be a double bond between carbon and carbon only, and alkyne will be when the triple bond between the carbon and carbon only. Is it okay, everyone? Because we can form carbon triple bond nitrogen. Yes. But that will not be a alkyne. Alkyne will be what? When there is a triple bond between carbon and carbon or double bond between the carbon and carbon, then alkene and alkyne will be formed. Is it okay, everyone? Fine. Any doubt? No. Come to the next point. So alkynes, we have seen triple bond, propyne, ethine. Ethine is possible, but methane is not possible. We cannot make carbon with, this is not possible, right? With any hydrogen we cannot make. So carbon and triple bond carbon will be there, then only it will be a ethine. So alkyne group and alkene group will be starting at least from 2 carbon. Is it okay? But alkene group will be starting from the very first carbon, that is carbon number 1. Yes? Is it okay, everyone? Now, come to the next point. So now the next compound is what? About the cyclo or cyclic hydrocarbons. So these things we have seen these things in our previous chapter as well. Now the cyclic compounds we are going to learn, right guys? The saturated and unsaturated hydrocarbon may also contain chains or rings of carbon atoms in their molecules. These are known as cyclo or cyclic hydrocarbons. Is that okay? Now this is what? Cyclopropane, cyclobutane, cyclopentane, cyclohexane, now cyclopropene. So there will be a double bond will be there here, right? At least one double bond will be there, so it will be called as cyclopropene. Cyclobutene, cyclopentene, cyclohexene, these are what? Cyclohexane. But every cyclohexane is not a benzene. Getting my point? So there will be an alternate double bond should be there in cyclohexene, then only it will be a benzene. This is also a cyclohexene. Yes, but this is not a benzene. Yes or no, guys? Please correct me if I am wrong. So will every cyclohexane will be a benzene? Benzene is a six carbon molecule, right? And there must be a double bond in conjugation, right? In entire ring. Getting my point? Entire ring there will be a double bond will be spreaded, right? At alternate positions. Is it okay? Or the best way to understand these things is what? The partial bond will be spreaded all over the carbon in benzene ring. But partial bond is not any concept in organic chemistry. So that why we are doing so, we are two partial bond we are combining and seeing one single bond at alternate positions. Is it okay, everyone? Getting my point or not? Please tell me. See, what is this partial bond? See, actually the benzene structure is like this, right? Partial bond. So somewhere you might be seeing that like this as well. Somewhere you will be seeing like this as well. So this partial half bond in here and partial half bond here, this will be combining to form one single bond. So benzene is having what? At alternate position we are having a single bond between the carbon atom. Is it okay? Any problem to anyone? No? Fine? Okay. Come to the next point. So this is what cyclohexene. So every cyclohexene will not be a benzene. So there is a condition that alternate double bonds should be there. Now, aromatic hydrocarbons. What are these aromatic hydrocarbons? These are hydrocarbons which contain at least one special type of hexagonal ring of 6 carbon atom with double bond in the alternate positions that I have told you earlier as well. The ring is called aromatic ring or benzene ring as well. So this is what? Benzene. This is what? Toluene. Toluene, guys. Do you remember? Actually, there is a 7 carbon is there in this whole system. 1, 2, 3, 4, 5, 6 and 1 carbon more. So total number of carbon is what? 7 carbon. And this is toluene is the, it is at like we are calling our pets some with some good names, right? Or even you are also called some by a very good name in your home, right? At your house. Your mom might be calling you Kaniska to Kannu, but now when you are going to your school, the Kaniska and whatever be the surname is there, all things are there, right? Is it okay? So toluene is what? Toluene is what? That is pet name, calling name, right? But the IUPAC nomenclature of this toluene is something different, right? What is the IUPAC name of this toluene? Can we say methyl benzene? Yes, methyl benzene. Fine, guys. Okay. So this is what? Ethyl benzene. 2 carbon will be there. This is what? Oxy. If O, see guys, if two group is there, so what we can call this? 1,2 dimethyl benzene. 1,2. We can take any position at 1 and any position to 2. 1,2 dimethyl and benzene will be there. So it will be what? 1,2 dimethyl benzene. Or we can also say 1,2 dimethyl cyclohexene. Getting my point? So if you are saying benzene, so there is no need of cyclo word. But if there is not benzene word is used, then you have to use what? Cyclohexene. Is it okay, everyone? No. This is naphthalene. Again, this is common name. Anthracene, this is again a common name. So now you will be asking, sir, if these are having alternate positions, they are having double bond, right? This is okay, fine. Double, single, double, single, double, single, double, single is there. This is good. This is also double bond at alternate position. Double bond, single bond, double bond, single bond, double bond, single bond. This is also fine. This is aromatic compound. This is also fine. That is single, double, 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 single, right? But what about this carbon? See, guys, if I am starting from here, single. If I am starting from here, single. Again here single is there, right? Again single is there. So how, you may ask me that, so then how it is an aromatic compound? You have told me earlier that at alternate position there must be what? A double bond should be there, right? Yes or no, guys? But I'm saying this is an aromatic compound. So how this is an aromatic compound? Can anyone tell me the answer for this question? How this is aromatic then? Guys, please tell me. If you are having your answer, then don't hesitate to give the answer. And teacher will not come out from the screen to do anything, right? You can give your answer. You are free to give your answer.
Sir, it is like a figure 8, sir.
Yes, yes. Tell me once again.
Is it like a figure 8, sir? Like,
see, we can do one thing. Let's suppose we have started from here. This is single, then double, then again single, then double, then single, right? Or we can rotate like this: double, single, double, single, double, single, double, single, then again double, and then single, then double. So this is what? Pi bond is at alternate position in both the ring. Although this ring is shown as what? Two double bond, but this double bond will be working for this double bond as well. Else, what will be happening? This is a carbon, right? If let's suppose, if you are not thinking like this, so what will happen? This is also carbon. So I can draw like this, carbon and carbon, right? So this is one bond. So I'm drawing one bond, right? And this carbon is also having bond with this carbon and this carbon as well. So there are two bonds with this carbon. It is fine, everyone? Is it fine, everyone? Any doubt? Now, one double bond is also there. So let's suppose if I'm making one double bond here, right? Now, think about this carbon again. So this bond, two bond, right? So two bond here. And if I will be making another double bond here, so this bond, if I am making here double bond, right? This is a double bond for me. So this carbon will be having how many bonds? 5 bonds. This carbon will be having what? 5 bonds. Let's see like this. Getting my point, everyone? Now you can see here, this carbon is having how many bonds? 1, 2, 3, 4, 5. So is it possible for carbon to make 5 bonds? Guys, what do you think? Is it possible for carbon to make 5 bonds? So there is something inside this carbon, right? So what is that I have told you? Is it okay, everyone? Any doubt? If there is any doubt, then please let me know. Fine. So double bond is in conjugation in both the ring, so that it's a aromatic hydrocarbon, right? Now, same goes with this carbon, this chain as well. If you will go double, single, double, single, double, single, double, single, double, or you can go like this: double, single, double, single, double, single, double, single, double, double, single, single, double, single, double, double, single, double. So this is like this. This is a game only, right? So double, single game will be there. So this is what aromatic carbon is there, right? Although we will be learning about the conditions as well in the later part of the class, right? Now, fine. So see here, alkanes. So you can see here that carbon-carbon single bond will be there. Propane will be the example. Cycloalkanes, carbon-carbon will be between the single bonds will be there, and there will be a cyclic ring will be there. So there is one major difference in alkanes and cycloalkanes. And what is the difference? See here. Let's suppose we are having 3 carbon chain there, right? So we are having how many hydrogens here? 3 hydrogen, 2 hydrogen, again 3 hydrogen, right, everyone? Any doubt? So the formula will be what? C3 and H3 plus 2, 5 plus 3, 8. So 3 C. But if you are going to make cycloalkane, cyclopropane, so now you can see here that this carbon, so there can be 2 hydrogen, right? Because carbon has made 2 bonds with this carbon, right? Again here there is what? 2 hydrogen. Again here there will be what? 2 hydrogen. So the formula will become what? C3H6. So there is a difference of what? There is a difference of 2 hydrogen here. Getting my point, everyone? So what is the basic difference between the propane and cyclopropane? What is the basic difference, guys? So there is a difference of 2 hydrogen here in this case. Yes? Any doubt? No? Fine. So same goes with C here. What happens with alkenes? So double bond will be there. This is what propene. We have seen these things. Cycloalkenes, what will be there? See guys, any double bond is coming, so it will take 2 hydrogen at least. At least not 2 hydrogen will be. So there will be what? There will be what? We have to give two hydrogens to form one single bond. Yes or no, guys? Yes or no? What do you think? There is a cost of 2 hydrogen for forming one double bond. Yes or no? So we have to pay the cost for that. Then only we can form what? Double bond between the carbon. So here you can see here. You can see here. So 6-member ring is there, right? So C6. How many hydrogens should be there? So see here, 2 should be there. 2 should be there, right? So total number of hydrogens should be what? C6, H12 should be there, right? But we have formed one double bond. So here we have to subtract this 2 hydrogen, right? So there will be what? C10, H10 will C6, H10 will be the formula for this. What do you say, guys? Am I right here? Yes or no, guys? Please tell me. What do you think about this? So for one double bond, there is a what? We have to pay the cost for one double bond. We have to give what? 2 hydrogens, and there is a double bond has been formed. Now, so what about this triple bond? Triple bond, see guys. So carbon, triple bond carbon. So this is what? Propane. Now, is it possible to form triple bond between benzene or any cyclic compound? So let's suppose if you are forming triple bond here, one double bond is there, right? And now if you are forming one triple bond, so carbon, see here, see guys, please try to understand here. Carbon is here is also carbon. carbon can form what? 4 bonds. So 1 bond here, 1 bond here, right? 2 bond, 1 bond here, 3 bond, 1 bond here, 4 bonds. So is it possible? What do you think? Can you please tell me? Is it possible? Is it possible or not? Can you please tell me, guys? No. Why no? Why no, Vishnu Priya? If I will say yes, then? If I will say yes, then? See, 1 carbon is there, right? Carbon can form how many bonds? See, let's suppose there is no double bond is there, right? 1 double bond is there. Now, is it any hydrogen with this carbon? No. Now I'm going to make the structure first. See, let's suppose we are having this compound, right? Now, how many hydrogens we can put with this? 2 hydrogens, right? And 2 hydrogens with this as well, right? Now we are forming 1 bond. So this 2 hydrogen has gone. Now again, if I will be going to form the 1 double bond, so this 2 hydrogen will be gone. So there can be a possible of triple bond, right? Yes or no? What do you say? Vishnu Priya? Is it okay? So there can be, but consecutively if you will be going to find, so we should check whether it will be a possible to form consecutive triple bond or not. Triple bond in consecutive order. If you will be going to find triple bond with this carbon now, this bond. So here if you will be going to form triple bond, so what will happen? This carbon, so triple bond, right? And this carbon is having again triple bond with this side. So how you will be going to form? Is it possible? No? Fine everyone? No. So alkanes are saturated hydrocarbon containing only carbon-carbon single bond in their molecule. They are also called paraffins. That is Latin words, right? So got my point everyone? This name is justified because under normal condition of temperature and pressure, alkanes are inert and do not react with reagents like acids, bases. Alkanes are inert and do not react with reagents like acid, base and oxidizing agent and reducing agent. However, under drastic conditions at high temperature and pressures, alkanes do undergo some reactions. The alkanes may be divided as what? See here. Open chain or cyclic alkanes, cycloalkanes or cyclic alkanes. See these pictures, then we will be discussing. Fine everyone. Now, open chain or acyclic alkanes. Open chain or acyclic alkanes. These are simple alkanes without any closed chain and have general formula CnH2n plus 2. Right? So, open chain will be having what? CnH2n plus 2. This is the general formula. Yes? Anyone who is trying to speak anything? I'm available to talk. If anyone? No one? Okay, fine. I request those guys, those who are turned off their camera, so please turn on your camera. Now it's the time for show. So please turn on your camera, right? Don't turn off your camera. Last chapter is going on. So we are in the last stage of our journey of this 11th standard. Everything has been finished. So we are in the last chapter, so please have some focus on this chapter because this is going to be very important, right? Now, come to the next point. So guys, so this is what CH4 we have seen, propane we have seen, butane we have seen, so many times we have seen these things, so I'm not going to discuss this, right? Now, cyclopropane we have seen. Either we can make like this or either we can like this. This is same. So if you, there will be no any question in your examination if you are writing like this or if you are writing like this, right? Cyclobutane. So you might have heard in your, you might have learned these things in your earlier standard, 7th, 8th, 9th. This is what, beta? This is square, or this is what? There can be rectangle. But in what? In organic chemistry, this is what? Not this is a square or this is not rectangle. This is what? Cyclobutane. Fine, everyone. So please don't say, if any will be asking you, what is this? So yes, sir, this is a square. No, sir, this is a rectangle. So don't messed up these things in your organic chemistry. This is what? This is cyclobutane inside, and cyclopropane will be there. So triangle, cyclopropane, a square or a rectangle, there will be what? Cyclobutane will be there. There will be no square, there will be no rectangle will be there. There will be only the one thing, that is what? Cyclobutane will be there. If double bond comes in between them, so cyclobutane will be there, right? So pentagon will be also there. Hexagon will be also there. These figures of mathematics will be coming here, and that will be denoting something else that you might be knowing now, I hope. Getting my point, everyone? No. Even you will be going to know, board form, chair form. In organic chemistry, you will be learning so many things from the daily life. What is the chair form, board form, that we will be going to see. Seahorse form, right? Now. So these things we have seen, right? Methane. Now, this is what? This is known as what? CH3 group is known as what? Alkyl group. I have told you so many times that if one hydrogen is replaced in any case, so this methane will turn into what? Methyl. Yes or no, guys? If 2 carbon is there, there must be 6 hydrogen. If 1 hydrogen has been removed, so it will be now C2H5. So C2H5 is nothing. This is what? Ethyl. Yes or no? Tell me, guys. Ethyl. So there can be what? Ethyl, propyl, butyl, pentyl, hexyl. Is it okay? And these are worked as a substituent in any carbon chain. These are worked as a substituent in the carbon chain. Is it okay, everyone? No. So now we are going to see the structures for this alkane. How the structure of alkane is there. So spatial arrangement of this methane you can see here. Methane, carbon, hydrogen, 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 hydrogen is there. So can we say this is a square planar, this is a tetrahedral, or this is a rectangular structure? What is this? Guys, what do you say about the alkanes? What is the structure of alkane? Is it tetrahedral or it is a square planar? What do you say? Can anyone give me the answer for this question? What are you saying, guys? Is this a tetrahedral molecule or not? DRT is giving the right answer, that is tetrahedral structure is there. If it could be a square planar, so there must be like this, square. Right? So one carbon will be there, and this will be the arrangement of this square planar. But alkane is not a square planar, it is what? A tetrahedral. Is it fine, everyone? Now, you can see here that carbon is formed, carbon is having what? Which carbon is having the arrangement of what? sp3 hybridization. What is the hybridization of this carbon here? sp3 hybridized. Yes or no, guys? I have given you so many times the trick for this, finding this, what? Whether it will be a sp2 hybridization, whether it will be sp3 hybridization, whether it will be a sp hybridization. So I have given you so many times about the tricks of this to find the hybridization. Is it fine? Any doubt to anyone? No? No. So this I am not going to teach you, guys. You have seen so many times methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, right? So no, now I'm not going to see this. Nonane, decane. undecane 11, dodecane 12, icosane 20, triacnotane. This will be what? 30. So nonane, decane, undecane, dodecane, icosane, this will be what? This 11, 12, 13, sorry, 20, that you, if you are learning, then it is okay. Otherwise, it will not be in your work, right? It will not come in your path. Never. Because I have seen so many compounds, but their undecane and dodecane and icosane has not been is not coming, right? From 11 to 12, if you will be going to find, there will be no any compound of like this, right? So till 8, it is fine. Till 8, it is fine. Now, these are some, nomenclature that we have done in our past lectures as well. So guys, I hope I'm very much confident from your side that you will be able to give the answer for this question without seeing the answer here. See guys, how we have done the nomenclature for this kind of questions. See, this is a special case, right? That's why I'm writing here. CH3 is there, yes or no? We can count our carbon from 1, 2, 3, 4, or we can do 1, 2, 3, 4. Here we are getting the maximum branches. That's why we have started our counting from here. Else we can start our counting from 4th number carbon as well. But we cannot do like this because we are not full guys. We are what? We are super intelligent. Why? We are great Indians. Why? Because I have told you the things that the counting will be from there from where we will be getting from where the least count of the C, from which side we will be getting the earliest possible substituent or functional group. Yes or no, guys? So earliest possible substituent is where from the carbon number left to right when we are going. Yes or no? So examiner will try to make you full, but you don't have to do like that. So you'll have to start your counting from where there will be the maximum number of substituent are there. See here there are only, with one carbon only the two substituents are there, right? But there can be a case where there will be one substituent from the left and two substituent from the right. So then what you will be going to do at that time? I have told you one more thing, that from where there will be the maximum branches are there, from there you have to start your counting. Yes or no, guys? Yes or no? Am I able to make you understand or not? Getting my point? So I'm going to draw first so that you will be able to understand more. See, let's suppose here there is carbon, right? Here one carbon is there, right? CH3 is there, like this. CH3 is there. Yes or no? Now, it is coming at second number. Now here from this side, if I'm coming, here there is CH3 is there, and again this is 2CH3 there, right? So we'll be starting our counting from where? From 1, 2, 3. This will be our counting, or it will be 1, 2, 3, 4. What should be? From right to left or left to right? What should be our counting, guys? What do you think? Please write in the chat section, left to right or right to left. I don't think that there will be any confusion to any student, because I hope it is very much clear to each and everyone. What should be our counting? Left to right or right to left? Guys, I don't want to wait for your answer. I just want to get your quick answer in this question. This is only, lollipop questions are there. Right to left, Vishnupriya right to left, Kanishka right to left. Everyone is giving right to left answer. This is the most correct answer. This is the correct answer. Getting my point? So now you have understood these things. So now you can give easily this answer. 2-methyl pentane. This will be what? 3-methyl hexane. See guys, you might be thinking, sir, CH2CH3 group is there, right? CH2CH3 group is there, so it is ethyl. So why should we not count this as a ethyl? I'm making this structure, and then I will let you know how this is not ethyl and how this is coming in the main chain. Getting my point, everyone? See here. Let's suppose, see, actually the counting has been not given properly, but I am making this here. Here this is what? 1, 2, 3, 4, 5 carbon is there, right? 5 carbon. This is the 5 carbon, right? Now here 2 carbons are there, right? This is what? C2H5, let's suppose I'm saying. C2H5 is there, right? Now, if you will going to open the C2H5, so can we write like this? Carbon, and carbon. C2H5, this is what? C2H5, yes or no guys, please tell me. C2H5. Now, again here there is what? C is there. So main chain will be what? What will be our main chain? This will be our main chain now. This would be our main chain, guys. And this will be what? This will be act as what? Substituent only. What do you say? Am I correct or not? This is an eye-opener question, guys. Eye-opener question. So people generally do mistake in this type of question. I have taken so many demos and I have seen that almost every student are doing, each and every student doing the same mistake. That is, they are saying that this is what? 2-methyl pentane. If it will come to your examination, definitely you will be giving the right answer that C2H5 is in this upper position. So it will be a 2-methyl, 2-ethyl pentane will be the right answer for this question. And this will be coming the first option only. And you will hit that option only. Yes or no? If it will be coming, so you will be doing what? Yes, 1, 2, sir has told me, sir, yes, 2, 1, 2, 3, 4, 5 is there. So this is what ethyl group is there. So 2-ethyl pentane will be there. Yes, this is the right answer and this is coming the first option. So no need to check the other options, right? But guys, you have to check very seriously, right? There is what? There's something, if this type of question is coming, there must be a lollipop type of question in there. So you have to check whether it is lollipop or not. So this is what? This is not ethyl. This is what? This will be counting in the main carbon chain. And the right option will be what? 3. 1, 2, 3. 3-methyl. 3-methyl. Hexane should be the right answer. 3-methyl. Hexane should be the right answer for this question. Yes or no, guys? What do you think? Am I correct or not? No, sir, you are not correct. After some time, the answer will be coming from your side. No, sir, you are not correct. What do you say? Netara, am I correct? Yes, yes, sir, you are. Okay, fine. Thank you. Now, see here, guys. So these are some miscellaneous type of question, guys. So we need to practice this. That's why I have taken in this slides, right? So please don't see this answer, right? Try to give the answer from your side only. Please have a note in your notebook. Take 5 minutes. Even if you are doing wrong, I'm okay. Even if you are doing wrong, I'm very much okay. I'm saying you very frankly. If you are doing wrong, that's okay. But you need to understand. You need to practice. If there will be anything wrong, I will be here to make you correct here, so that you can understand the things. But don't copy the answer. Try to write the question first. Right? This is the question. 4 questions are there, and try in your notebook and then tell me the right answer. If it will be correct, then also it's good. If it is not correct, then I will be making you the correct, that how you can do the correct answer. Once you are done with this, please tell me. So guys, done? What do you say? Are you ready to give the answer? Kaniska, Nitara, Anusika, Ashwin, Karthik, Vishnu, Priya. Guys, please write your answer in the chat section from very first to fourth one. Yes, I will see. Kaniska, Tara, please write your answer in the chat section. What you have written for the first question, Kaniska? 4 ethyl, 2 methyl, then hexane. Okay. Second question, Netara, please write your answer. Guys, everybody please write your answer in the chat section. From very first to fourth number. First write your answer, then I will check. Yes, guys. So what is the right answer for this question? So this one is correct. That is what? 4 ethyl, 1, 2, 3, 4, 5, 6. So 4 ethyl and 2 methyl hexane. That is correct. Okay. This one. So if we are counting from here 1, 2, 3 and from right to left 1, 2, 3. So here we have got what? Methyl at the second position. That's why we will be counting from right to left, right? In the second question, guys, we'll be starting our counting from the right to left. Why? Because at the very second position we have got methyl group, and from left to right at third position we have got what? That two methyl groups. See, actually what? 1, 2, 3, 4 carbons are there. So we can count like this: 1, 2, 3, 4, 5, 6. 6 carbon are there. Is it okay? 6 carbons are there in the straight chain. So we are having what? 1 methyl is here, and again there is ethylese group. Ethyl group is there, right? So can we say that 2 methyl and 4 methyl? So at two positions there are methyl group are there. So can we say, because this group is what? Ethyl. So 4 ethyl and 2,4 dimethyl and hexane. Yes or no? So the right answers are coming from your side as well. 4 ethyl, 2 methyl. Guys, 4 ethyl, 2,4 dimethyl hexane. Yes, good answer. But what about this carbon? What about this chain? What do you say about this? Okay, one more thing, that can we check like this: 1, 2, 3, 4, 5, 6. From here also we are having 6 carbon. So it's better to go through the straight chain only, right? Now, for this carbon chain number third, we are having what? 1, 2, 3, 4, 5, 6, 7. 7 carbons are there, right? At fifth position. So why should we count like from left to right? Why can't we count from the right to left? 1, 2, 3. Third positions we are having what? 3 carbon chains are there. What do you say? Even if we are counting from bottom to top, 1, 2, 3, and fourth position, we are having this part. 1, 2, 3, 4. Fourth position, we are having what? Ethyl group, right? And we can have a long chain that is 1, 2, 3, 4, 5, 6, 7, 8. 8 will be there. What do you say? What is the right answer for this question? Question number third, guys. What do you say? What is the right answer for this question? 1, 2, 3, 4. Or we can do or we can do what? See, if let's suppose if we are coming from the left to right, right? And from right to left as well, there are total 7 carbon are there, right? 1, 2, 3, 4. Actually, and from 1, 2, 3, 4. 1, 2, 3, 4. Actually, this is, see, this is at not fifth position, this is at fourth position. So there is some minor change in this chain. This carbon is attached with fourth number. Getting my point? 1, 2, 3, 4. 1, 2, 3, 4. So now, what should be your right answer for this question? If it is attached as fourth number carbon, and with that carbon, two carbons are again attached. So can we say like this? 4. See guys, 4. As fourth number, there is what? A carbon is present, and that carbon is attached to another two carbon. What do you say? Yes or no? At fourth position, one carbon is there, and that carbon is attached to another two carbon. So what we can say about this? Can anyone tell me what the right answer for this question? See guys. Can we start our counting like this? 1, 2, 3, 4. And this carbon is at, see actually the real figure is not here, right? So 4, 1 methyl, 1 methyl, ethyl. Just give me a moment. I'm bringing the right questions, right? So till the time, leave this question. What about this question? Is anyone has done this question? What do you say? What is the right answer for this question? Anyone has done this question? See guys, I think this is easy one. This is not so hard. How many carbon chains are there? 8 carbon in a straight chain. At second position, CH3 is there. At fifth position, CH2, CH3 is there, right? This is ethyl. And at seventh position, there is methyl group is again attached. So what should be the right answer for this question? 4 ethyl and 2,7 dimethyl octane is the right answer for this question, right? Have you done this question or not? Please tell me, guys. Kaniska, Anusika, is this the right answer? You guys also have done like this only? Nitara? Question number third, you all are, you all are worried about this. So I'm bringing the correct question, then we will discuss. This is a question, guys. Please tell me how you will be doing how you will be doing the answer for this question. What do you say? What is the right answer for this question? Let's try this question, right? And if you are done with this question, write in the chat section. And have a break of 5 minutes after that, 5 to 7 minutes. Then we will back, right? Yes, everyone. What is your answer? What do you think about this question? Yes, guys. Anyone is having any answer for this question? No one is having any answer for this question. What do you say? See, guys, what is there? At fourth position, the 3 carbons are there, right? One is directly attached and 2 is attached laterally, right? So it will be what? Isopropyl. It will be what? Isopropyl, and number of carbon that is in the main chain will be what? That is heptane. So we can say at fourth position isopropyl is there. So fourth isopropyl heptane will be the right answer for this question. Is it okay? At fourth position, a carbon that is attached with what? Like this. Is it okay? And this is what? 2 degree carbon. 2 degree carbon means what? Sorry. See, if it is attached, this carbon, if this is what? 2 degree carbon or 3 degree carbon? What do you say? This is not 2 degree, this is 3 degree carbon. Right? What do you say, guys? Because this carbon is attached by three carbon, so this is what? 3 degree carbon, right? This is not 2 degree carbon. So there can be some different name, right? We will check with this, then I will let you know. Now, next, see about this. How we can name this compound? Now this is easy one, right? From if you will be going to count from left to right, this will be, at third position you will be getting this carbon. From first carbon, if you are counting from right to left, at second position you will be getting 2-methyl, and at fourth position also 2-methyl. So 2, 2 and 4, 4. Tetramethyl hexane. Guys, you might have not seen this type of question ever. 2, 2 and 4, 4. Tetramethyl, and 6 carbon is there, so hexane. Right? So this is done. Now, see about this question. So we cannot start our counting from right to left, because at second position we are having 2-methyl group, right? So 3-ethyl, see here. And 2, 2 dimethyl hexane will be there. If 1, 2, 3, 4, 5, not 6, 5 will be there. So it will be what? Pentane. Clear, everyone? Any doubt? No? Now, next question. See here. There are total 10 carbons are there, right? This is a special case, you can say. Generally, we are not bringing this type of question, but for your improvement only, please see here. Total number of carbon is what? 10, right? At fifth position, we are having what? This long group is there, right? And at fourth position also, we are having what? CH, 2. Getting my point? CH, 2. So how we can start our counting, and from where we should count our counting? See, at fourth position, a methyl group is attached, and that methyl group is attached with what? That is, you can say, CH3 group. And that is what? 2 CH3 group is there. Is it okay? So we can say what? 4 and 1 methyl and ethyl. 2 CH3 group is there. See here. So 1 CH is attached with another CH, guys. 2 CH, right? So it will be what? 4, 1 methyl, ethyl. And fifth position, there is what? At fifth position, we are having what? 4 carbons. So what we will be calling for this? Just a minute. I am checking whether the structure is correct or not. Just a minute. Yes, 4 carbon are there, right? So this is what? This will be what? 4 isopropyl decane. So total number of carbon is what? 10. So you can see here, these are the special cases. You can do one thing, you can check at your home as well, and you can, you can do it twice at home. So this is, the things that I am saying, this is what you can do in different manners. And what will be the right answer for this question? Guys, what we are having here? At fifth position, what we are having? Total number of carbon, first open that. First, open the total number of carbons in any chain, and then try to find the answer for that question. One more question we have taken. This one, CH3 is there. So how we can call this? Total number of carbon is what? 7. So this carbon is attached like this, right? Getting my point? So this is what? CH3, this is what? CH3, 2 CH3 group is there. So what we can call this? What we can call this about? What do you say, guys? At fifth position, CH is attached with another CH3 group. At fifth position, CH, actually here there will be what? CH will be there, and that will be attached with another 2 CH3 group. So the correct structure is what? See, I'm going to make this again, and you have to tell me the right name of this question. Carbon, carbon, carbon. Total number of carbon is what? 5, 6, 7, right? At third position, what is there? Sorry, if you will be counting from the right hand side, what is there? 1, 2, 3, 4, fifth. Here there is what? What group is there at fifth position? CH is there. CH is there. And this C is attached with another. Just a minute. This CH is attached with what? To another CH3 group. Is it okay? Here 6 and 7 is there. So what do you say? What will be the right answer for this question now? And one more thing is there. That is what? CH2 CH3 group is attached with what? Carbon number third. We are having what? CH2 CH3 group is there. And 2 CH2 CH3 group is there. CH2 CH3 is there. And again CH2 and CH3 group is there. Now do this question and tell me the right answer for this question. Guys, now I have made you easy for this question. I hope now you will be able to give the answer for this particular question. Guys, are you able to see class assessment? Please check and then please tell me. But you don't have to do now. Actually, we have to do something else. Like we have to discuss some more questions. Then you have to start your class assessment. Because there are only 6 questions are there. Then you will be able to do this, I hope, within few minutes only. So what is the right answer for this question, guys? What do you say? See guys, total number of carbon is what? Once again, I am going to give you one more carbon here. Then tell me. Then what is the right answer for this question? If total number of carbon is 8, and then this is the structure. So what will be the right answer for this question? See guys, can we say 3,3 diethyl? 3,3 diethyl. Can we say like this or not? Please tell me guys. 3,3 diethyl, right? And at 5th position, what is there? 3,3 diethyl, 4 methyl, or we can say what? 5 isopropyl, 5 isopropyl and 4 methyl octane. 4 methyl octane. What do you say? See guys, 4 methyl. Isopropyl, this is isopropyl, right? So 3,3 diethyl, 5 what? Isopropyl, and 4, what is this 4 at 4th position? What is having? 5 isopropyl, 4 methyl octane, 4 methyl octane. And remember guys, you have to always write this methyl and octane with like, there will be a joining will be there. There will be no gap between the methyl and octane. Got my point? So 3,3 diethyl, 5 isopropyl, methyl octane. So 4 methyl octane. Is it fine? In other word, how we can write 3,3 diethyl, 4 methyl, and at 5th position we are having what? 1 methyl, 2 ethyl. We can write like what? 1 methyl, 2 ethyl octane. Is it okay? 1 methyl ethyl, 1 methyl ethyl and octane. Do you want to see guys how we can write like this? See. 3,3 diethyl, 4 methyl, 5, and in bracket we will be writing what? 5, 1 methyl. We will be writing like this: 5, 1 methyl, and then ethyl. Then total number of carbon count and write that. 1 methyl ethyl. That will be with same 1 methyl ethyl, and total number of carbon is what? Octane. 8 carbon is there, so it will be what? Octane. Fine, everyone. So we can write in two manners. Is it okay? So should we move to another question? Are you done with this? No. So we have done the same question here, right? 3 ethyl, 3,3 diethyl, 5 isopropyl, 4 methyl octane, or 3,3 diethyl, 4 methyl, 5 1 methyl ethyl octane, guys. We have done this question. These are, mind washing, you can say one of the hardest question of this, a whole hydrocarbon nomenclature. You will be not getting this type of question ever. Like in IIT examination only, you will be getting this type of question. You might be not seeing in your book as well. There are some questions are there, but these are not much. But once you will be able to do this type of question, if you will be able to handle this, I hope you will be having a good nomenclature system. Right? Now, one more question we are going to see. See here, how many carbons are there? Total number of carbons are 9. Right? Now, with fifth carbon, you can see here, 1, 2, 3. Another groups are a test. So how we will be writing like this? See guys, we have to start our counting. Let 1, 2, 3, 4, 5, or we can write, we can count from right to left. 1, 2, 3, 4, 5. Either from the left or either from the right, the same number is coming for fifth position, right? Fifth position. And at this position, we are having what? 2, 2 dimethyl. See here, what we are having? 1, 2. At 2 position, what we are having? 2, 2 dimethyl, and propane is there, right? So 3 carbons in a straight chain we are having. So what we can call for this? What do you say? What we can call for this? 5, 2, 2 dimethyl propyl. This all will be in bracket. 2, 2 dimethyl propyl will be in bracket and nonane. Is it okay? Fine, everyone? Any doubt to anyone? No? So 5, 2, 2 dimethyl propyl nonane will be the right answer for this question. Now, see guys, these are what? These are cyclic structures. So we have done so many questions like this. This is what? Ethyl cyclopentane. C2H5 is there. This is, I hope this is in your practice now. C2H5 is what? Ethyl. So ethyl cyclopentane. Here what is there? CH3 group is there, right? And we can count from anywhere. Like we can take this CH3 at 1 position and this CH3 at third position, right? And 1, 3 dimethyl cyclohexane will be the right answer for this question. Hope you are understanding these things. Here CH3 group is what? If let's suppose this is CH3 group, right? Or here it is what? C2H5 is there, right? This is C2H5 must be there. So that's why then only the question will be completed. 1 ethyl, 2 methyl, cyclopentane. We will not be start our counting from right like this. 1, then 2, then 3, then 4, and then 5. We have to start, we have to do like that. In which manner we are getting the first the locants, right? First the substituents that are attached. So if you will be moving from, if you will be moving like this, then it will be the right option. If you will be moving like this, then it will be a wrong option. Why? Because at fifth position we will be going to get this CH3. So it's better 1 and then 2. 1 and then 2. It's ethyl. So we have taken that nomenclature system that according to alphabetical. So ethyl will be coming first, then methyl will be coming. Is it okay? Any doubt to anyone? Now see here. What we can call about this? 1 methyl, 3 propyl cyclopentane, 1 methyl, 3, see here, 1 methyl, 3 propyl, M and OP. Guys, P is coming later, so we'll be taking what? Methyl first. So 1 methyl, 3 propyl, cyclopentane will be the right answer for this question. What do you say? Is it okay? Any doubt to anyone? No doubt. Hope you are understanding, guys. No doubts. Now, next question. Next question is about what? This is what? See guys, this is nothing here. So this is what? A square is there, and after that 1, 2, 3, 4 carbons are there. So how you will be going to name this compound? 4 carbon chains are outside this. What do you say? See guys, we can say like this: 1 methyl propyl, 1 methyl propyl, and cyclobutane. 1 methyl propyl and cyclobutane. Next question. See guys, C2H5 will be there, not S3 will be there, right? So this will be what? And we are having CH3 group is there, right? So how we can call this? How we can call this, guys? Please tell me. See, we are having what? C2H5 is there and CH3 is there, right? So we have to start our counting in such a way that everything should be in the least count, right? Let's suppose if you are going to start from here, 1, 1, 2, 3, then you have to come like this. So it will be at what? 4, 5, 6, 7th position you will be getting this methyl, right? So we cannot do like this. We have to start our counting like this: 1, 2, and then 3, and then this 4. So 2-ethyl, 1, 4, 1, 4, dimethyl cycloheptane is there, right? Total number of carbon is what? 7. So 2-ethyl, 1, 4 dimethyl cyclopentane is there. Is it okay? Fine, everyone.